So, not knowing in advance exactly what we would do with the extra time, we asked 4 of our speakers to be on a panel, but we also promised all of you at the beginning of the day an opportunity to ask any of our speakers, including Mia, who spoke in the plenary, any questions you might have. So I'm going to use this portable microphone to try and get them on the mics, but and this is really, I'd like to begin by opening this to those of you who are not part of our group that's making the presentations or invited to participate in our post-conference workshop. So it's really to those of you who consider yourself practitioners and came here to learn a little bit more about what molecular methods could bring to understanding the indoor microbiome, please feel free to let me know if you have a question. I don't know if I can catch you on the mic, but I'm not going to throw it to you. Yes, of course.
I'm this type of guy. I like air sampling, and I'm quite impressed.
Wait a second. And then turn it on. Turn it on and speak into it. And don't block the camera, which is right behind you. The switch is on the top.
Yeah, thank you. I enjoyed these many presentations and eager to ask questions. So finally we're there. Thank you. And my introduction to my question, of course, was that air sampling I like. I'm this air type of guy very much. But also maybe I'm a little disappointed that these many presentations concerning air sampling and the advances of air sampling didn't talk much about settling velocities.
About what?
Yeah, that the spores settle quite quickly. So I think these air samplers, they may be rather noisy. And often air sampling is done in empty rooms, because when the air sampling is running, then we can't do teaching, we can't have children, we can't be at home. So what about preconditioning, and is this an issue? And I don't really know who to pose the question to, but those doing air sampling, do they precondition? And what are the requirements for activity in the room while they sample?
I'm not sure.
Well, at least for the practical situation, it's... So when we are discussing about the practical situation, when you are looking for an abnormal source...
You have to turn it on.
Okay. So in the practical situation, when you are looking for an abnormal source, we are telling that you should have the same situation as normal, so that you would have like normal activity there. But there is a lot of discussion about that. Should you somehow make the dust pressure send into the air, some kind of activity, like even blowing up the dust. But then you should have also the reference measures done by that way. So at least at the moment, all our reference material is collected with normal activity, with not with this kind of active or this, what is it, aggressive sampling. Tina, do you want to say something?
When it's on and it moves.
I think, well, in terms of I'm not sure about the Anderson pumps, they need quite a bit of flow, but for our button sample collection, there are pumps in there that we have, that we actually place in classrooms during teaching hours and so on. So they are fairly silent getting there, I think. So I think that's feasible to be done.
What is the air sampling rate?
Well, for button, it's 4 liters per minute for a longer period of time.
Please, no questions after all that? No, you're not allowed to ask a question, Jordan. You have to answer the question. Well, no, if we have no other questions, then...
Question here.
Okay, Bit? Yeah, well, two things. I wasn't going to ask the question, but it's just been raised. The time of sampling is obviously is critical because the standard sampling we've been using is 4 to 6 minutes or very short times, and because of the large fluctuation in temporal biological activity in the air, then does anyone have any solution? What was the sampler that you were saying that takes longer time? What sort of time?
It's just you take a filter sample, it's a button inhalable aerosol sampler.
Okay, right. The real question I was going to ask, we're having fantastic problems with transitioning to other technologies. We've been using the micrometer now for a couple of years, and all of our standards and all of our legislation is based upon culturable methods. The problem is, as we've just heard, that cultural methods pick up 1% of the total, whereas the reality is there's so much more.
That's a myth.
Sorry, that's a myth.
That's a myth.
Oh, good. Okay, fine. That's the debate. So we're finding that the cultural methods have very large variability, 30-40% in terms of their reproducibility, whereas the new methods are plus or minus, say, 5%. So if anyone has any tips in this area, that'd be great, because we're right in the middle of ISO 17025 assessment for this and trying to get those new technologies into place. And the question is, how do they compare to cultural methods? And we find that the comparison is sometimes difficult to show.
Any of my experts want to respond to that?
I think the 1% is coming from bacteriology, and I don't know why.
In our research also, we saw it with the fungi also.
Well,
I think at some stages it works. I think it varies so much, and it's really comparing apple and pears, and I think it's a really big problem to compare culture to the other ones, because they're measuring something fundamentally different.
I'll give you my non-expert digestion of what I just heard. With the DNA methods, some large multiple of the organisms that have been identified by culture methods have now been identified. But if I understand, if I know what organism I'm looking for, and I pick a culture-based method that's good at it, we're not talking about 1%, we're talking about, you know, something up in the range of what Martin talked about. In terms of not knowing what you're looking for and trying to see what's there, then I think we're talking about a large multiple with the DNA, but without the quantification that you get. And then we get into the details of methodology, but please correct me if I'm wrong. You look like you're in pain from what I just said. No? Okay.
Well, about the culturability, I think there are some papers that have shown with the air samples that with fungi and it is like 1%, but that's like homes and offices. But like in the farming situation, it can be even 60-70% of the that you see with the direct microscope counting, and then you compare it to the viable thing. It can be even 60 to 70. So it depends where you are measuring, how alive it is, and so. But I think at the worst it can be very, very low.
So these are important foundation questions for what we want to talk about in the workshop this afternoon, which is, from a very naive point of view, why should anybody who's been using culture methods or hasn't been looking at microbes indoors at all want to use the molecular methods? And if so, what are the problems that they see? What are the challenges and what are the barriers? That's what we hope out of our program here in the conference, to come away with your questions and comments and challenges, and then we as a group, the scientists, will try to come up with how that can be addressed. So keep going. Yeah.
I have a comment about the culturing air samples. What you get on air samples depends also very much on the ventilation that you have in the room. So this is an indirect method. I think the best thing to do is to go and do a good research in the building directly. Go for the damage directly.
I'm not just talking about air samples, I'm talking about all samples.
About old?
All samples.
What do you mean
Either
old
swab-
samples?
Either swab or water or air. The information we're getting is that there's so many more total plate count, so much higher total plate count. We're seriously underestimating
Yes.
the material that's actually there. The second point is that culture methods, when you use point plate as an aggregate, if you put 1,000 bacteria on particles, you count 1 count.
Well, depending on the bacteria, I guess, but
No, it's the physics.
when you take a contact plate on the surface,
Marie, you have to repeat his comment because he didn't have a microphone when we were recording.
I think you better.
Okay, sorry. No, the other fundamental problem is that bacteria do aggregate on, let's say, a dust particle or something like that. And so if you do a normal dispersion without doing very aggressive dispersion, you're basically counting that organism as one count on the plate.
Yeah. Yes, it's true. It depends on the bacteria species again. But what is important to bear in mind is that maybe when you are using agar plates directly on building surfaces, you are getting dormant organisms which are not doing much. And these are background levels. Go for organisms which are growing in the building. Then you can find damage. We don't live in sterile buildings, don't forget that. If you are giving molds water and nutrients, they're going to grow. But if you leave them on the surfaces they are, maybe they won't wake up.
You make it very difficult because of where you are in the room, but we'll go over here first.
Thank you. Is it on? Anybody hear me?
Yes.
Good, okay. Comment on the culturability of fungi. It really depends on what medium you use. For instance, if you only use DG18, you will not get any of the high water activity fungi, as Christian was talking about this morning. If you use, a lot of medical facilities use saprophytic, or what is it called? Some reddish medium. Others use DRBC. And if you use that kind of medium, you select already for the fungus that will grow on there. So a wide variety of cultural media, and you can actually grow, I would stake my pension that you can grow 95% of what is actually growing in the buildings.
Not growing, present.
Okay, present then, yes, there might be just dormant spores.
So I'd like to interject. We had a conversation in Hong Kong at the Indoor Air Conference, and Tom Bruns made the comment, it depends on what you want to know. So if you want to know who's there and you have no idea, then culture-based methods are going to be limited. If you know what you're looking for, then you have a better chance of finding it with the proper culture-based.
But if you, in a building, the materials that we are using in a building, there are limited numbers of materials we can use. And we have a pretty good idea by now what kind of fungus, what species that will grow on them. And then we know what to look for if we have, say, water damaged gypsum. We know which species to look for, and therefore we know what medium to use when we're looking. We also know whether they are going to be airborne or not airborne. So,
well, if you have confidence in that, that's fine. You know, I comment on a lot of the experts' presentation that is a carpet, wallboard, and ceiling tile. But I know I come at it from a completely different perspective. There are so many different variations on carpet, on wallboard, I mean, even gypsum board with paper can be highly variable depending on which plant manufactured it, and even the conditions, the weather, and so on that day. Not to mention the additives that they put in to make the slurry and so on. So these, it's dangerous to generalize, and there's a real role for assuming you don't know everything.
Oh yeah. I would never assume that I would know everything.
Well,
It's not a question, it's just a further comment on the original question about the differences in culturability. There's such a rich history between culturability and building variables and culturability and health impacts. And in order to make some sort of transition, if it does occur, between molecular methods and health impacts and building parameters, it's going to take a long time. And my gut instinct right now is that we'd learn so much more with culturability if you're looking at practical applications. The molecular methods, I think, still are a research topic, and it remains to be seen what's associated with moisture if you're using those techniques versus culturability. So right now, I think that's still an open question.
yeah, let Jack also comment on that, and then we're going to wrap it up for this morning, and we will resume at 1:30. But Jack was specifically invited to comment on this particular
I flew
question.
all the way here just to comment on that comment. So from my perspective, it's the merging of those two, as you just suggested, but both of them have implications for practicality, right? If I want to identify a bacteria that can suppress the germination of a fungal spore, I want to be able to do that in a correlative fashion by looking at genotypes of the bacteria and fungi which co-associate under dormant versus growth potential and germination situations. So I can see like these bacteria are always found alongside these fungi when they are sporulated, right, and not germinating. And then I can use that information to target which bacterial strains, and it's usually very, very genotype specific. So this bacterial subspecies is the one which does it, not this same subspecies, same strain, but from a different strain from the same species, has no effect. So if I can isolate which exact strain it is, then I can go in and target my analysis to identify practical solutions for biological control of fungal sporulation inside a built environment. This is what we do inside people's intestines and inside agricultural systems. We utilize those techniques. The culturability is our validation that our assessment of the correlations between two genotypic specific indices are accurate. Both techniques have horrendous biases, right? Which PCR primers you use will screw yourself up, and which sequencing technology you use will change your analysis. That's irrelevant almost if you have enough data to deal with the ability to derive specific correlations between particular points within an experimental setup. So everything comes down to the experiment and the question, which is what you said.
So to illustrate the importance of specificity, a lot of you probably think you're excellent detectors of national origin based on accent. How many of you think you know where he's from?
They're all European, of course they know where I'm from.
Where am I from? And when he said he flew here, how many of you assumed after you heard him speak that he flew here from Great Britain?
Apparently this is a thing for how I'm English, but I live in Chicago.
Okay, thank you very much. So we'll see you all back here at 1:30. That should give you enough time to get some lunch and to refine your questions, and we will continue the discussion.